Hello, welcome to this video about the performance of dplyer's select and filter functions in R. My name is Martin. Normally you see my face, but my webcam is not working properly, so let's do it quickly like this. So what I want to show you is normally I use from the dplyr package. That's so nice. Escape. The dplyr function, and I already got some data loaded. We use filter, and then I know one variable is called kt. I want it to be equal to ag, and we select. Oh my god, select institution, and I want to display the first and equal 10 rows of it. So here we go. Now the same of course can be done with the native base R functions, which you would call like this: data and $kt equal to ag, and you select in the institution column, and let's not use a pipe operator, just make a proper function m equal 10. Now this will be more efficient in terms of computing power that it needs, because the pipe operators they are kind of they are function, yes, that are called, and also filter and select to be called individually instead of selecting it as such, and will take a little bit longer. Now our question is how much longer does it take? So for this we have start that I assign system time. Oops. And we also have end, and we have end minus start. Yeah. And now let's call the first one and the second one, and after 0 length, it's not a variable, what the hell. Such, you see, it takes 0.023 seconds for the dplyer's version of the whole thing. Now do the same with the base R. Let's use this here. How long does it take? It takes 0.18, which is almost the same. Now I want to see this quantitatively, like for a larger sample, so let's use a loop of 100 times we do this, and more specifically we do start. Yes, let's use it as such. Yes, start. And actually let's make this, let's call this exactly 3 times. 3. Yeah. And instead of just printing this, we will assign it to times. And we call this I1. And we say this is end minus start. Let's assign the times should be a data frame. Now let's run this 100 times. Takes a couple of seconds, as it seems. And we have times one, and we use mean, And you see in the mean it takes 0.032 seconds. Now if we do the same, let's use also this. But instead of the dplyrs, select and filter, we use base R. Is this exactly also 3 times. And let's assign this to the second. Let's also run this. And you already see now it's considerably quicker. It only takes 0.02. So more than 10 times quicker. Now the question is how much on average. So let's do this for and run this j in 1 to 10. And I'll close it here. Now, of course, we can have times that we calculated in the first with the dplyr function divided by and also mean. Such, and I believe it's better if you put some brackets so it's clear. So yeah, 15 times quicker to use base R. And we will print this. And where does this one end? This is this one. So let's see, run this 10 times, each time 100 times, and see how much quicker it is, or how much slower it takes to use dplyr instead of base R. And does it print something? Yes, 18 times, 17 times, 17 times. So let's not run it 10 times. But you see it's on average around, we had the first one was 15 times slower. And we now got around 17. So it is considerably slower. Now this doesn't matter much in everyday's work when you just work on your own data set, but it does matter if you are, for example, deploying a Shiny app, or if you have a lot of data wrangling going on in the background when you build a RMarkdown document. So in this case, of course, it will result that the user or that you have to wait considerably longer for deployment. So that's what I wanted to show. If you using Shiny, if you're using RMarkdown and you have the choice, rather maybe go for the base R version of it because it's quicker. Thanks for watching. Goodbye.